Good afternoon, everybody. Allow me to start the lecture discussion. For this afternoon, we will discuss all about naming and writing formulas of inorganic compounds. Now, when we talk about the names and chemical formulas of any substances, these are considered essential or significant vocabularies in chemistry, meaning to say, important in a way na for us to find information of a particular substance, of course, the first thing that we should know is to name and to write the formula of that compounds before we proceed to identifying its properties, physical, chemical properties. We have to learn first what is the name of that compound, how do we write the formula of that compound. In general, naming of substances that is called chemical nomenclature. Nomenclature, this comes from the Latin words nomen, which means to name, and then clature, that comes from the Latin word calere, which means to call. So, overall, if we combine the two Latin words extracting the name nomenclature, this is all about system of names. System of names or list of names. Now, to name most of the compounds, may it be organic or inorganic compounds, we rely on systematic set of rules. And that rules are set or provided by the IUPAC community, or what we call the International Union of Pure and Applied Chemistry. So they are the ones who provided the systematic rules to follow in naming compounds, may it be organic, inorganic. So later on the preceding slides, we'll discuss the rules in naming inorganic compounds, may it be ionic or covalent compounds. Okay, so we have set of rules to follow. Although there are some substances that have been or have been known already for a long time using their traditional name or what we call the common name. Example, the compound H2O. Instead of calling, diba, this compound using its systematic name, which is dihydrogen monoxide, of course, we use the name water. Okay, so that's the common name or the traditional name of H2O. It's water. Okay, so we have certain, no, certain or few substances that uh, wherein their common names or traditional names has been widely accepted already in the chemistry community instead of using their systematic way of naming. Diba? When we buy bottled water, we don't say, can I buy dihydrogen monoxide? Instead, we use the common, diba? The common name, water. Another example, NH3. So instead of calling this using the systematic name na nitrogen trihydride, this is commonly known with its traditional name, which is ammonia. Okay, so we have that. We have that certain substances na mas kilala or more commonly known for their traditional names. Okay, so these are just few examples. But for the preceding slides, we will learn more of their systematic names, no, following the rules set by the IUPAC. Okay, so before we start, let's have a bit glance with the periodic table of elements. Kindly take note that the elements, no, all in the periodic table, they are arranged based on atomic number. You try to observe the arrangement from 1, 2, 3, 4, 5, so on and so forth, that they are arranged based on atomic number. Aside from that, the elements are also grouped by period and with their vertical grouping, which is by group. Okay, so we have the vertical grouping that is from top to bottom. Okay, so vertical line, that is the group number. one way how we group the elements in the periodic table. Another, the horizontal grouping. Horizontal grouping meaning from left to right, horizontal line. That's the period number. So these are just two ways how we group the elements in the periodic table: vertical grouping, horizontal grouping, the period, and then the group number. What else? Kindly practice also, no? Or be familiar or have that photographic memory on the positioning of the elements in the periodic table. Let's say when you are asked for the position of the non-metals in the periodic table, they are always placed on the upper right, no, upper right portion of the periodic table. So this part. And then those elements that lie along this staircase, this one, okay, I highlighted with color sky blue, that one. These are the elements that are considered metalloids, or what we call semi-metals, meaning they exhibit that metallic and non-metallic property. And the rest, to the left, these are metals. Okay, so please take note of the arrangement of the elements. The non-metals on the leftmost, non-metals on the right, no, upper right portion of the periodic table. Okay, so we'll start. Regarding names and formulas of compounds, starting with ionic compounds. So with the term compounds itself, you know this by definition. Compounds, any uh, combination, diba, of two or more different atoms. As long as it consists already of two or more different atoms, then we consider that as a compound. Excuse me. Now, when you say compounds, inorganic compounds, we can classify them generally into two. We have ionic and then the covalent compounds. When you say ionic compounds, let's extract again the terms. Okay, ionic. So from the word ions, ions, these are charged atom, and there are two types of ions: the positively charged and the negatively charged ions. We have the cation ions, positively charged, and then the anions. So by definition, if you just understand the term ionic compound, this is a combination of cations and anions. So two different atoms. Okay, atoms with positively charged, but atoms that are positively charged and atoms that are negatively charged. Okay, let's recall. Talking about cations, recalling that among the elements in the periodic table, the metals are the ones that tend to form cations because during chemical reaction, remember metals, example sodium, potassium, magnesium, diba? These are found on the leftmost part of the periodic table. Okay, during chemical reaction, they tend to lose electrons. So when they lose electrons, they loses electrons, they will carry positive charge. So nag-reduce ng negatively charged particles that makes their atoms carry positive charges. That's why they form cations during chemical reaction. Whereas non-metals like the halogens like chlorine, fluorine, or iodine, what else? Nitrogen, oxygen, those elements on the upper right portion of the periodic table, as I have presented earlier, the periodic table, those non-metals during chemical reaction, they tend to gain. Tama? They gain electrons during chemical reaction. That's why when they gain electrons that are negatively charged, what will happen to that atom? They will become highly negative as well. That's why they will become or tend to form anion. Anion are negatively charged atom. Okay? So that's why I've mentioned earlier, when you say ionic compound, that is just a combination of a cation and an anion. or simply saying combination of a metal plus a non-metal. Okay, so later when we write formula, chemical formula of any ionic compound, you'll get to realize that it's really a combination of a metal first, followed by a non-metal. Now, in naming any ionic compound, always the cation comes first, the name. Now, the name of the cation comes first, followed by the anion. Okay, so let's say, for example, uh, we have a cation of sodium, and then the anion chloride. Diba? I told you to memorize list of ions and their names. So sodium and chloride. Then if we are to extract what compound, what ionic compound can be formed out of these ions, then we could tell that the compound, ionic compound that can be formed out of this combined ions would be sodium chloride. Kasi you have sodium and you have a chloride. Now, what if you are asked to write for the formula? Formula of these given compounds, sodium chloride, an ionic compound. You just have to uh, extract no, the ions that you memorize. Diba? Sodium, it's Na plus. Chloride, it's Cl negative 1. And then follow the rule, crisscross method. That's it. To write the formula, that's crisscross. Crisscross method. What is crisscross method? Crisscross method is you simply cross over, no, cross over the numerical value of their charges, making them a subscript of the other ions. Okay, they become subscript. Uh, uh, where is it? Ayan. Again, the numerical value, the numbers, no, the numbers of the charges. Of course, if there's no number in the charge, it means 1. The charge is simply 1. So the numerical value there will become subscript of the other ion. So you just cross over the numerical charges. So that becomes NaCl. Take note, subscript of 1. Let me take it note ha, dire. Subscript of 1 is not anymore written. It's not anymore written. Okay, that's it. That's the rule in writing ionic compound. You just have to cross over the number, the numerical value of the charges. Disregard the charges. Disregard the charges when you write the final formula. This is the final chemical formula. Okay, let's have another example. Let's say the given is, let me write it here. Example, the given is calcium and then fluoride. Okay, again, when you write the name of that compound that you can extract out of this ion combination, the name would start with the cation followed by the anion. So this will become calcium. But the name of that ion is calcium. And then followed by F negative, that would be fluoride. So that's the name. Now let's say this is the given name of the compound and you are asked to write the chemical formula. How will you write the chemical formula of this compound, ionic compound? So you just have to extract. That's why extract the ion form of calcium and the ion form of fluoride. That's why I tell you to really memorize the ions as early as, when was that? During our class orientation, di ba? I told you to memorize the list of ions. So you have to extract. Calcium is Ca2 plus, fluoride ion, F negative. So to write the formula, what would be the formula? Crisscross. You cross over the numerical charges. Okay, try to observe. The calcium here will not have a subscript, no imaginary one, because the numerical charge of fluoride here is only 1. So you don't have to write a subscript for calcium, but for fluoride, it will be followed by a subscript of 2. Where does it come from? From the charge, numerical charge of calcium. So again, just cross over. Cross over the numerical value of the charges. Disregard the charge itself. Okay, you don't need the charges when you write this. Sorry, uh, it, it, it has been deleted. Okay, so just take note of that, or you can just access again the recorded video. Okay, so that's it. Now, for more examples, we'll have that later. Before we continue, no more examples about naming and writing formulas of ionic compounds. Let us know first how ions are being named. How do we name cations? How are anions being named? Okay, so let's find out. First, cations. Okay, so cations, first type, we have types of cations that are extracted, yes, from metals. And when you observe their name, they just have the same name as their metal name. Diba? When you try to observe the list of cations you have in your notes, the name of their ion, the name of the ion of the cations extracted from metals, they just have the same name as their metal name. Example, extracting the ion form of sodium, which is Na plus. If it becomes an ion of sodium, its name is still sodium. Okay, it's still sodium ion. Zinc, aluminum, lead, and the rest. No, the rest of the metals, when they form cations, when they carry charges already, they just have the same name as their metal. So that's the first type of ions. Okay. Now, for those ions formed from a single atom, they are specifically termed as monoatomic ions. How do you know it's single atom? There is no subscript. Okay, there's no subscript written on the right part, right side bottom part. No, so single atom lang. So that's monoatomic. Mono means one. Mono means one. So if the ion only contains one atom, then that is also known as monoatomic ion. Okay. So example are the given above. No, the rest. Okay, ayan. The rest of the examples you have there in your notes, the one that I provided to you, the list of ions. Okay, so the given example here are all monoatomic ion because they are just single atom carrying a charge. Now, if you will be asked, is mercury 1 considered monoatomic? What will be your answer? Is it a yes or a no? What would be your answer given the formula of mercury 1? Do you consider this as a single atom? Okay, obviously not. No, because it has a subscript of 2, meaning it is a combination of 2 ions of mercury 1. Okay, that's why we produced Hg2, then add the charges 2 plus. Okay, and please take note that this is the most stable form of mercury 1. That's why in the list of ions that I provided to you, observe the formula. Observe the formula of the ion mercury 1. Diba? It has a subscript of 2 because that's the most stable ion form of mercury, a combination of 2 ions of mercury 1. That's why Hg2, 2 plus. But again, this is just uh, to know the difference between monoatomic and a diatomic or polyatomic. This is already considered polyatomic because it contains 2 atoms. Okay, 2 or more atoms present in that ion form, it's already polyatomic. Okay, so these metals found on the to the left, leftmost part of the periodic table, they form again cations. Okay, when I say cations, positively charged. Ayan. And for mercury, mercury 1 particularly, it forms diatomic ion for mercury 1. Okay, second type. Let's proceed to the second type of cations. You will also observe na upon memorizing the names of cations, there are certain ions with Roman numerals. Have you observed that? Example for iron. We have two forms of cation iron. We have iron 2, iron 3, wherein yung 2 and 3 are represented with a Roman numeral. Those are actually charges. Okay, charge of that ion. Okay, so those are examples of metal capable to form cations with variable or varying charges. Okay, so when you say varying charges, they can form more than one charge. Okay, what are those examples? Metals that are considered part of transition metals. Where do we locate the transition metals? This portion of the periodic table, the middle portion, the middle part of the periodic table, the metals found there are transition metals. And they are capable to form variable charges. Okay, let's try to highlight some of them. Example, copper. Try to check in your list of ions. Diba copper has Cu+. We also have copper that is 2+. So we have copper 1, copper 2. What else? Iron. Iron has 2 charges. We have iron 2. We also have iron 3. Okay? So going back to this statement, it says that for those metals that can form varying charges, how do we name them? Look at their name. Observe their name. They follow following the name of the metal. Following the name of the metal would be the charge, which is represented by a Roman numeral enclosed in a parenthesis. That is why, diba, have you observed the iron, the iron with a symbol Fe? When you name it, there are Roman numerals 2 and 3. Those Roman numerals, they represent the charge. So it's a hint, no? So if it says copper 1, so meaning to say that copper has positive 1 charge. Copper 2, it means it has a charge of 2. Chromium 3, so that would be a chromium with a positive 3 charge. Okay, so this is actually the systematic name. Systematic name, or kumbaga the new name of the cations capable of forming varying charges. Okay, so let's try to list some of them. Okay, let's list them. So example, again, we have copper. We have copper 1. We also have copper 2. Try to check on your notes, ha. Iron, we have iron 2. We also have iron 3. What else? Chromium. As mentioned, we have chromium 2 and the 3. Chromium 3. Cobalt, we also have this example as part of the transition metal. We have 2 and we have cobalt 3. We also have lead. Lead has a charge 2, and we have lead with a charge of 4, 4 plus. Mercury, another good example, no? Mercury 1, what is again the most stable? Most stable ion form of mercury 1 is Hg2, 2 plus. Then we have iron 2 without subscript, with a charge 2 plus. So that's another example, no, of a transition metal with varying charges or differing charges. More than one yung charges. What else? Manganese. We have manganese 2. Sorry, it's Mn. Mn. Manganese 2, and we also have manganese 3. And then we also have gold. I think it's not written, no? The gold 1, only gold 3 is written. Then kindly add bismuth as well. No, bismuth 3 and bismuth 5. What else? Tin. Tin also. Tin 2, tin 4. Okay, so again, if you name this using the systematic way of naming, you simply name the metal. So the name of the metal, copper, iron, chromium, cobalt, so on and so forth. So after the name of the metal, in a parenthesis, you have to write a Roman numeral representing their charge. Okay, so do not forget that. When, example, you are uh, asked to name this compound, okay, so you have a copper and a chloride. So for this cation, copper, so that is obviously copper, di ba? Kay Cu is the elemental symbol of the metal copper. So that is obviously copper. But what type of copper is that? Remember, it is capable of differing charges. Is it copper 1 or copper 2? Sige, can you identify if it is copper 1 or copper 2 based on the formula? If I told you when you write the formula, you cross over the charges. So what do you think is that form of copper? Is it copper 1 or copper 2? Okay, very good. It's actually copper 2, no? Because looking at the formula of the compound, uh, you are seeing a subscript 2 placed after chloride. Okay? That comes from the charge, the value, or the numerical value of the charge copper. Diba? Galing lang po yan sa copper 2 plus crossover to it becomes a subscript of the chloride. Okay, chloride atom. So that's why you produce copper 2 chloride here. Okay, so that's it. So when you name it, you have to identify if it is copper 1 or copper 2. So that's my point here. Okay, for those metals capable of forming varying charges, you should not forget, no, the form of that ion if it is capable of varying charges. Again, remember copper, it has two forms. Make sure to identify if it is 1 or 2. Okay, what else? Regarding these metals, transition metals, aside from their systematic name or new name, this one, diba, this is the systematic name. After the name of the metal, you write the Roman numeral enclosed in a parenthesis representing their charge. Aside from the systematic name, we actually have a traditional name, or what we call old old method of naming these ions that are that tend to form differing charges of or variable charges. So regarding the older method, this is more widely used compared to this one. Okay, so I need you to be familiar with the traditional name of these ions as well. The traditional name of these ions makes use of the suffixes ik and us. Okay, so when is ik added to the name of the metal? When is us added? Okay, the ik suffix, this is added, or this represents the higher charge. This represents the higher charge. Try to observe. For copper, one has lower charge, the other one has higher charge. So you know already which should ends with an ik. Us is to represent the one with the lower charge. Okay? So ik and us are just suffixes. When you say suffix, added to the last part, tama? Ending, kumaga, ending part of the word. Okay. Particularly, they are added to the root name of the or added to the Latin name, rather. They are added to the Latin name of the element. Example, copper. It comes from the Latin name cuprum. Okay? So the ending will just be replaced with an ik or us suffixes. Okay? So you can have either a kuprik or a kuprus. But which of which is the kuprus and the kuprik? If I will ask you, for the first encircled copper ion, is it cuprous or cupric? Based on this concept, is it cuprous or cupric? Go. Or you can just answer the suffixes. Okay, the one with us, no ending. So this will become cuprus. Why? I told you the us ending or us suffix represents the one with the lower charge. It is added to the ending of the Latin name of the element with the lower charge. Okay, then this becomes cupric. Next, iron. Iron comes from the Latin word ferrum. So you know already which will become ferrous, which is ferric. No, so this will become ferrous and this one ferric. Ik, suffix for higher charge. Okay. Next, for chromium and cobalt, we simply use the name na chromium and also cobalt. So for chromium, it's chromus, and this one chromic. Ito cobaltus, cobaltic. Next, for lead, it comes from the Latin word plumbum. Okay? Sige, you tell me. What do you think would be the traditional name of the first encircled ion of lead? Okay, that becomes plumbus. Okay, this is plumbus and this one plumbic. Okay, next. The first encircled ion of mercury. Is that mercurus or mercuric? Which is mercury 1, which is mercury 2. Okay, since this is mercury 1, this has the lower charge. Okay, so this is mercurus. And this one, this is mercury 2, right? So the one with the higher charge, mercuric. Next, this is manganese, manganic, and then aurus, auric. Kindly add this in your notes. And then for tin, it comes from the Latin name stannum. Okay, stannum. So we can extract the name stannus and stannic. So this is stannus, stannic. Okay. For bismuth, we simply use the systematic name. Bismuth, the name of the metal followed by the charge represented using Roman numeral. Okay, Roman numeral 3. So bismuth 3 enclosed in a parenthesis in Roman numeral, and then bismuth 5 enclosed the Roman numeral 5 in a parenthesis. Okay, so these are the examples of transition metals that are capable to form uh, varying charges. And what was that? No. Uh, Ma'am, dili na siya gamiton na No. Hydrargenum, hydrargyrum, that is the Latin name of the element itself. Okay? What we are discussing is the ion name of the elements. Okay? So for these ions, okay, extracted from transition metals, again, they are capable of forming differing charges. And we have two possible names that you can use, the systematic name wherein it is more easier, right? Because you just have to name the metal. After naming the metal, enclose in a parenthesis the charge represented using a Roman numeral. Or if you think this is more convenient for you, the traditional name, then you can also use this. Okay, so I have to share this to you, the traditional name, because there will be, I believe, there will be questions later on in your laboratory exam or even in your lecture exam. Now you will be asked to write the formula of, let's say, cuprous nitrate. Okay, so you need to be familiar, no, with the Latin, the traditional name of these ions. Because cuprous, di ba, cuprous is the traditional name of copper 1 here. That's cuprous ion. So just recall that the ous ending is to represent the one with the lower charge. The ik ending represents the one with a higher charge. Yeah, correct. Clarifying lang po, most, mostly kay gigamitin sa ilang Latin names po. Yeah. Yes, majority with an us ending and ik ending, they are added to the root name of their Latin names. Yes, correct. Okay. Okay, so you just have to memorize. Again, I always keep reminding you, no, to memorize the ions, the formulas of the ions. So this is just an additional information. Just know the us, when is us used, and the ik. Again, this is only applied to those ions capable of forming varying charges or differing charges. And these are few examples. Uh, Common confusion by my students in the previous semester is they always confused aluminum as an example of an ion with variable charges. Please take note that aluminum is constant. It will only carry a charge of 3 plus, no other charges. It's not even part of the transition metals. Try to check in your periodic table. Diba? Aluminum is not part of the transition metal, so it's not capable of forming varying charges. Okay? So that's it for the second type of cation. Okay, and then last, you can also observe, diba, after you read the list of ions, there are few ending in "-um". The name of that ion, cation, ends with "-um". Those are actually extracted from non-metal atoms. Example, ammonium. Ammonium that consists of the non-metal nitrogen and hydrogen. Okay, so in combination, NH4 plus, since yung characteristic niya acts like alkali metals, it is considered cations. Okay, when during chemical reaction, they loses, no, uh, electron. That's why they form cation. So just take note of this. The most common one is ammonium, and there will be more examples of inorganic compounds wherein you will be exposed to na yung formula niya contains ammonium ion. So please take note, do not forget, no, ammonium ion, it is a cation, NH4 plus. And for this given example, these are considered polyatomic ions. Poly means many. So try to observe the formula. They contain not only one, but many atoms. For example, for ammonium, it has nitrogen and then 4 moles of hydrogen. So it's already poly. Okay, polyatomic ion. So that's it for cations. So somehow you were able to understand why those cations that you memorized. There are some with Roman numerals, there are some without, those ions with ending IUM. Okay, so this will help you realize the names of the cations. Next, let's proceed with anions, how they are named. You will observe, di ba, when you memorize the anions, the one with negative charges, there are ending in IDE, IDE. We also have anions ending in 8, and there are also ending in IT. Okay, so let's try to find out how they are named, what ions or what atoms forms ending IDE. Okay, so first, single atom, a monoatomic anion or a single anion. They have names by simply replacing the ending of their name with an IDE. Okay, so when you encounter a non-metal, for example, chlorine, fluorine, nitrogen, oxygen, diba, these are monoatom, one atom only, single atom. When they form their ion form, so let me write the ion form of this non-metals. We have Cl negative, F negative, uh, nitrogen, or N3 negative, oxygen 2 negative. These are already ion or anions of the non-metal. Uh, if it is a monoatomic anion, the name of their ions will now end with IDE. So this is not anymore chlorine. You change the ending INE to IDE. So that becomes chloride. Okay, so since it is monoatomic, again, if it is monoatomic, single atom only of a non-metal, and then it forms ion, particularly anion, change the ending of their name to IDE. So this is not fluorine, but fluoride. Again, because it's already anion. Nitrogen, from nitrogen, this becomes nitride. Oxygen, this becomes oxide. What else? Selenium. This is not already selenium. Kindly change in your list of anions. I think it is still selenium, but this is actually selenide. Okay, it should end with an IDE. Following this rule. Okay, it's selenide. What else? Phosphorus. From phosphorus, if we extract the anion form of phosphorus, it becomes phosphide. Diba? So ending in IDE sila if it is monoatomic. Although there are few, very few only. Let me erase this part. We have very few polyatomic anion that also ends with IDE. There are only three of them. Okay, so three of them. Just take note of this. Hydroxide, peroxide, cyanide, but there are polyatomic already kasi it's not only a single atom, but a combination of different atoms or combination of more than one atom. Okay, so these are a polyatomic anion that ends with ID. There are only three of them. Then the rest of the monoatomic single anion, single atom anions, they end with IDE. Okay? Sulfur. Diba? Kung you extract the ion form of sulfur, that's 2 negative. Okay? So that becomes, instead of sulfur, that becomes sulfide. It's monoatomic. So it should end with IDE. So that's the reason why all monoatomic when anion, they end with IDE. So that applies for single atom anion. Next, let us proceed to polyatomic anion. Okay, majority of the anions listed, the one that I provided to you, the copy that I provided to you, majority are polyatomic anion, and they end with 8 and I suffixes. Those are specifically oxyanions. They are considered oxyanions. What do you mean by oxyanions? Uh, Meaning to say, in the formula, there is presence of oxygen. And when you observe the name, they end with an eight or I. Okay, so for you to easily memorize these oxyanions, all you need to first kumbaga memorize or get familiarized are the common ones. Just memorize the common oxyanion of an element, those ending in 8. Example, let me have the empty slide. Again let me write it first. You have to memorize only the common oxyanion of elements. Elements, particularly nonmetals, kasi we're talking about anion. Diba, nonmetals are the ones that form anions. Okay? And again, the common oxyanion of the elements are those that ends with 8. 8 suffixes. Example, for chlorine, its common oxyanion is actually chlorate. Again, those ending in 8. And what is its formula? It's ClO 3 negative. For bromine, diba, it's bromate. And bromate has the ion form BrO3. What else? Nitrogen, diba, that is nitrate. So its common oxy, an ion, is NO3 negative. What else? Iodine, that's iodate. Okay, and its common oxyanion, IO3 negative. What else? Sulfur, diba, it's sulfate. And its formula is SO4 2 negative. What else? Phosphorus, phosphate. That's the common oxyanion of the element phosphorus. And its formula PO3, PO4 3 negative. So we have nitrogen, sulfur, bromine, iodine. We also have tin. Okay, common uh, oxyanion of the element tin is stannate. Okay, how do we write the formula of stannate? SNO4. Wait. SNO3. I think, tama ba? SNO3. 2 negative. So that is stannate. Okay, so that's it. Just memorize the common oxyanion of the element, those ending in 8. Once you memorize it, you can easily extract the ith form. How do you extract the ith form? It is used for an oxyanion that has the same charge but one less oxygen from the 8th form. Okay, try to observe this. From the common oxyanion of nitrogen, nitrate, NO3 negative, one less oxygen from nitrate, it now becomes ith. Okay, so that's why I only emphasize the most common oxyanion. Once you memorize the most common oxyanion, then one less oxygen from that, you can extract the ith form. Another example from sulfate. Remember, sulfate is the common oxyanion of the element sulfur. So from this formula of sulfate, one less oxygen from sulfate, that becomes sulfite, the ith form. Okay, so same lang yung charge, same charge. It will not change, only the number of oxygen. One less oxygen to form the ith form. Okay, sige, let me ask you, your turn. Let's say the given is bromate. What's the ith form? the ith form of bromate. Given this concept, one less oxygen of the eighth form. So that becomes ith. How do you extract bromite out of bromate? Sige, go. What's the formula? It's, okay, it's BrO2, negative. One less oxygen lang from the eighth form. Okay. What about iodide? Sige, go ahead. Your turn. I will wait. Make use of the chat box. What's the iodide form of iodate? Again, it's one less oxygen. Okay. So it's IO2. That's it. Okay. So again, just memorize the common oxyanion. If you memorize that, you can easily extract the ith form. So no need to memorize everything. Do not memorize everything, ha? So that you will not be confused with the formula. Okay? So that's it. For sulfite, to extract sulfite, one less oxygen from sulfate. So SO3, 2 negative. The same charge, only the number of oxygen will change. One less. This is one less oxygen atom from the eighth form. That's it. So you continue the rest. Okay, in your notes, you continue filling in the information, the ith form. Next, we also have oxyanions that could extend to four members. Okay, you will observe upon memorizing the ions, diba, we have prefixes like per, ayan, example, perchlorate. You also have prefixes hypo, example, hypochlorite, hypobromite, perbromate. Okay, so kindly take note that for halogens, bromine, chlorine, and iodine, they are capable to extend to four members of their oxyanion. Okay, let's go back to the example, chlorate. Diba? This is the common oxyanion of the halogen chlorine. It's chlorate ClO3 negative. I told you that when it is one less oxygen from chlorate, it becomes chlorite. Okay, this can actually extend to four members of oxy and ion. You can use the prefix per and hypo. So when is the prefix per used? It is one more oxygen atom from eight, from the eighth form. So meaning from ClO3, if it becomes ClO4 negative, that's the time you add per from the name chlorate, prefix per. So that becomes perchlorate. All right? So it still boils down to memorize only the common oxyanion. Then just know when is per being used, when it becomes ith. Okay? Next, hypo. The prefix hypo, this time it indicates one less oxygen from the oxyanion ith. So from chlorite, it becomes hypochlorite if one less oxygen from chlorite. Okay, remember hypo prefix means super low. Low level, reduced form. That's it. That's hypo. That's why among the four members, this ion form has least number of oxygen. That's why it's named as hypochlorite. And the rest of the halogens, bromine and iodine, they can also extend to four members of oxy and ion. So you can just make use of your available time or during your independent time study. Try to write the four members of oxy and ion of bromine and iodine. So ganun din, we have perbromate, bromate, bromite, hypobromite. We have per iodate, iodate, iodite, and hypoiodite. Again, this four members only applies to the three halogens. That's it. Okay? So for these two slides, the point is really memorize the oxy and ion, the common oxy and ion. And these are the following. Okay? If you memorize that, one less oxygen, that becomes ite. One more oxygen from the ate ending, you add per prefix. And one less oxygen from the ion ite, that becomes hypo. Okay, hypo form of the anion or oxy anion. So that's it. That's how we name anions. Okay, so we can now proceed to combination of cations plus anions forming ionic compounds. Okay, so before we proceed to the next slide, you try to answer this. Make use of the chat box. How do you extract the formula selenite from this given ion selenate? So you go ahead. What's the selenite ion form? Mm-hmm. Okay, what about the others? Okay, I only have two students. Sige, so only two students, three students are present for today. Next time ha, if you will not participate in the class, I will not record anymore all my discussion starting midterm. So I'll observe this class next time. Okay, so it's SeO3 2 negative. Okay, what about number 2? What's the hypobromite form of bromate? Okay, it's BrO negative. That's it. Sige, so let's try to name ionic compounds. So I already introduced the uh, method in writing ionic compounds. So let's just review. In naming ionic compounds, it consists of the cation name followed by the anion. So I emphasized this earlier. Cation first, followed by the anion. So try to observe all the names provided. Calcium, aluminum, and copper. These are all metals, right? Calcium, aluminum, copper, metals. These are cations. Whereas the remaining are anions. So that would be the arrangement. So chloride, nitrate, perchlorate, these are anions. So let's try to write the formula. So again, you have to memorize the ion form of these um, ions. Okay, so you have calcium ion Ca2 plus and chloride ion it's Cl negative. And to write the final chemical formula, you make use of the crisscross method. Again, in crisscross method, this numerical value of the charges, you cross it over and they become subscript of each other's ion. Okay, so calcium here will not carry any subscript because a subscript of 1 is just imaginary. And then Cl will be followed by a subscript of 2. Okay, So this is the final formula of, or chemical formula of calcium chloride. Next, aluminum. Aluminum is Al3 plus and nitrate NO3 negative. So crisscross. Crisscross method, try to observe what happens. Aluminum, no subscript because nitrate here, it has a charge of only -1. So one subscript of 1 is not written. So you can write immediately nitrate. What would be the charge? I mean, the subscript rather. So you tell me, what's the subscript of the nitrate ion? What's the subscript? Okay, 3. Now, listen. Whenever a polyatomic ion like nitrate, diba nitrate is a polyatomic ion. Whenever a polyatomic ion carries a subscript greater than 1, so that would be 2, 3, 4, so on and so forth, as long as greater than 1, we have to enclose it in a parenthesis before writing the subscript greater than 1. Okay? So that all the atoms from that polyatomic ion will receive the subscript of 3. Tendency, if you will not write a parenthesis, it will become 33 subscript. So you have to enclose the polyatomic, ha? This only applies to polyatomic ion. If they will be given a subscript greater than 1, we have to enclose them in a parenthesis. Okay, so that's the right way in writing formula of the ion. Okay, and then last, we have copper 2 perchlorate. So copper 2, it's Cu2 plus. Obviously, it's Cu2 plus because the given name has a Roman numeral of 2. So Cu2 plus. Perchlorate, from the chlorate ion, common oxyanion ion, it becomes perchlorate if one more oxygen from chlorate. So ClO4 negative, that's perchlorate. So you do the same crisscross method. You cross over the numerical charges. So yung copper here will have no subscript. And then it will be followed by perchlorate enclosed in a parenthesis followed by the subscript 2. Okay, so that's how you write the chemical formula. Okay, in your notes, kindly answer the following the opposite way. This time, you have to write the name of this chemical formula. Okay, so kindly copy. You have there another example. And then, okay. And then, okay. And last would be, okay, kindly copy this and then during your independent time study, try to give the name, chemical name this time. Chemical or the IUPAC name. Okay, these are all ionic compound. You will know it's ionic because these are written with cations first, followed by the anion. So all the underline first elements are cations. So the rest are anions. So you just have to name it. Okay? Sige, so that would be all for this afternoon.